Welcome to our discussion on best practices and code optimization, where we'll explore how to improve our programming habits. Our goal is to learn how to write Python code that is not only efficient, but also highly readable and easily maintainable. We begin with PEP8, which stands for Python Enhancement Proposal 8, the official style guide for Python code. PEP8 provides a set of essential conventions to ensure our code is consistently readable and understandable by everyone. First, let's look at the code layout guidelines to structure our Python files effectively. Always use 4 spaces for indentation, as this is the standard, and never use tabs in your Python code. It's best to limit all lines to 79 characters, and for docstrings or comments, aim for 72 characters. Use 2 blank lines for top-level function or class definitions, and 1 blank line before method definitions. Always order your imports by placing standard library imports first, followed by third-party, and then local application-specific imports. Next, let's discuss naming conventions, which are crucial for clear and consistent identification in your code. For variables and functions, use lowercase letters with underscores, like lowercase with underscores for readability. Class names should use CIAPITLIZEDWORDS, also known as CIAMEL for clear distinction from other identifiers. For constants, use a LL CIAPSWITHUND to signify that their values should not change during execution. Now, let's turn our attention to comments, an important aspect of documenting your code. Block comments should apply to the code that follows them and be indented to the same level for clarity. Inline comments should be separated by at least 2 spaces from the code and used sparingly, only when necessary. Finally, let's talk about docstrings, which provide essential documentation for modules, classes, and functions. Module docstrings describe the overall purpose of the file and should be placed at the very top of the module. Function and method docstrings should detail their parameters, what they return, and their specific purpose. Let's now apply these PEP8 guidelines to some Python code and see them in action. This example will demonstrate how to incorporate key style guidelines into your actual Python programming. Here, we'll start by defining a class and its constructor, following PEP8 recommendations. A class named EXAMPLECLSS is defined with its constructor, init. Both include docstrings, enclosed in triple quotes to explain their purpose. This code imports standard modules, defines an EXAMPLECLSS with a clear docstring, and initializes it with a value. Next, we'll implement a method within our class, demonstrating proper indentation and line length. The process value method showcases conditional logic, maintaining the 4-space indentation and adhering to line length limits. This method checks the instance's value and prints whether it's positive, negative, or 0, using clear conditional statements. Finally, we'll create a main function and set up the script for proper execution. The main function illustrates how to instantiate EXAMPLECLSS and call its process value method. The if name == main block ensures the script runs correctly. This part defines the main function, creates an EXAMPLECLSS instance, calls its method, and ensures the script executes when run directly. Beyond individual code style, organizing your entire codebase is vital for project success. These key practices are essential for building projects that are maintainable, scalable, and easy to collaborate on. First, consider your file and directory structure, as it forms the backbone of your project. Use meaningful names for files and directories, and always try to follow standard project layouts for consistency. Next, embrace modular design, which involves breaking down your code into manageable, independent parts. Break code into small, reusable functions, methods, classes, and modules, each handling a single, specific responsibility. Finally, consistent code ordering within your files significantly improves readability and navigation. Always place imports at the top of the file, Then define functions and methods in a logical and consistent sequence. Let's explore the various types of code documentation, which are essential for making your code clear and maintainable for everyone. Our goal here is to learn how to make your code truly understandable, not just for you, but for any developer who interacts with it. First up, we have inline comments, which are quick notes placed directly within your code to clarify specific lines. These comments concisely clarify complex or non-obvious code segments, appearing on the very same line as the code itself. Next, we have block comments, which are used for more extensive explanations that span multiple lines of code. They describe larger sections of code or complex algorithms, providing crucial context, and are typically indented to match the code. Then there are docstrings, a powerful form of documentation specific to Python, used for modules, classes, and functions. Docstrings summarize modules, classes, methods, and functions, detailing their parameters and what values they return. Finally, we have external documentation files, which provide a broader view of your project and its usage. READMES offer a project overview, while a PI documentation, often generated from docstrings, provides detailed usage instructions. Now, let's dive into some key performance optimization strategies that will help you enhance your code's efficiency and speed. Our focus here is on practical techniques to make your programs run faster and use resources more effectively. Algorithmic optimization involves selecting algorithms and data structures that inherently have lower time complexity for better performance. Code-level optimization means avoiding redundant calculations and minimizing expensive operations, especially when they are inside loops. Memory optimization focuses on managing memory usage efficiently, often by using generators for processing large data sets. Profiling and analysis involve using specialized tools to measure code performance and precisely identify any existing bottlenecks. Parallel processing allows us to utilize multithreading or multiprocessing, enabling concurrent execution of multiple tasks simultaneously. Caching implementation means storing the results of expensive function calls, thereby avoiding unnecessary recalculations in the future. Let's look at a concrete algorithmic optimization example to see how we can significantly improve performance. We will explore how to efficiently calculate the sum of natural numbers, showcasing a powerful optimization technique. Here, we'll use a direct formula to find the sum of numbers from 0 up to n-1. The formula is the sum from I equals 0 to n-1 of I, which equals n times n-1, all divided by 2. In this formula, I represents each individual number in the sequence that we are summing up, and n is the upper limit, exclusive of our sum, meaning the sequence goes up to n-1. The term n times n-1 divided by 2 is the direct mathematical formula to calculate this sum quickly. This elegant formula provides a constant time solution for efficiently summing any arithmetic progression, regardless of size. It cleverly avoids iterative loops, offering significant performance gains for large N compared to a slower linear approach. This mathematical optimization is a prime example of how algorithmic efficiency can dramatically improve your code's speed. Now, let's establish a structured debugging workflow, which is crucial for efficiently finding and fixing issues in your code. The first step in effective debugging is clearly identifying the issue, understanding what problem your code is experiencing. Next, you'll set breakpoints in your code, pausing execution at specific lines to inspect its state. Then, you'll step through your code line by line, carefully observing how variables change and execution flows. As you step, it's vital to inspect variables, checking their values to pinpoint where unexpected behavior occurs. Once the problem is identified, you'll apply a fix and then rigorously test your code to ensure the issue is resolved. Finally, review your changes and refactor the code if necessary, preventing similar bugs and improving overall quality. All right, let's wrap up our discussion with a concise summary of the key practices we've covered today. Here are the essential takeaways you should remember for developing robust, high-quality code in your projects. Firstly, always adhere to established style guides, such as PEP8, to ensure your code is readable and consistent for everyone. Next, remember to organize your code effectively using a modular design and maintaining clear, logical file structures. Thorough documentation is crucial. Use inline comments, block comments, and detailed docstrings to explain your code. To optimize performance, always choose efficient algorithms and strive to minimize any expensive or redundant operations. Furthermore, leverage profiling tools and caching strategies to effectively identify and resolve those pesky performance bottlenecks. Finally, employ a systematic debugging workflow, using tools like breakpoints and logging to efficiently resolve issues.